After that, we get the thousands. When I was in 4th grade, this was literally my least favorite part because it was like, okay, now we have the 10,000s, the 100,000s. What does this mean? It was not until I got older that I realized that it kind of just starts to repeat itself.
Yeah, it's repetitive.
Yes. I wish I had known that before. So right here, we're going to keep on going with the word thousands, but I'm going to go with, okay, well, ones is kind of repetitive because anything times 1 is the same thing.
Yeah.
So then here, I'm just going to add 10.
The 2,000s and
10,
then the 100,000s.
yeah. So knowing that we're going to just keep on going this way, what would be the next one? Right here. We did 10,000s, and we're just going to copy 1 from it. It would be 100,000s. Oh, let's see. My assistant wanted to say hello. Okay, so we have ones, tens, hundreds, thousands. And normally when we have a big number, this is where we start to see the little commas. Now, let's say we had another number over here, but I ran out of board space. That number would be called the million. So I can cheat, add another little number over here. This one is called the million. You know, when you win the lottery, the millions?
Yeah.
That would be very nice. However, our probability, which is another topic that we will be covering, is very low. So we start with ones, tens, hundreds. This is where we get into the commas, thousands, 10,000s, and 100,000s. At that point, we stop repeating the thousands. We're going to go ahead and say million. So let's say I have a really big number. Pardon that. So we have this. So going by this logic, so we know the commas, and thank goodness for the commas because they're very good placeholders. In other countries, they don't use commas, or they actually use dots instead, so it can be very confusing. So also we have our imaginary decimal point here, but since this is a whole number, we don't have any, if we're thinking of this like dollars, there's no cents, so we kind of just ignore it for now. So this would be the ones place. This is the tens place, the hundreds. We go over here to the thousands, 10,000s, 100,000, million. So we have 8, number 8. We have 7 in the tens place because it's only this little spot. The second spot right here is called the tens. The third spot is in the hundreds place. The fourth spot is the thousands place, which is number 8. This one is the next spot. This is the 10,000s, 100,000s, million. So I could say I have $7 million. If I just erase this, 7 in the front, I have $500,000. I go ahead and erase. I take off, so same here. I'm gonna go, can I erase this part?
Yes.
Go ahead and erase right here. So I'm left also with 6,000. So with this number, we'd actually call it
It would be 60,000.
60,000, because what's so here we have a 6, but times 10, we would call it 60,000. But we're going to be more correct. We're going to call it 68,278. But that's another, that's called the name, how you name something mathematically is different than its little spot. So we have the 10,000s. We're going to go ahead and erase this. So now we have the 8 right here. So this one, just like what we did with the 6 times 10, and we got the 60. Well, we just have the 8 because this is kind of like the 1 again, because it's the only thing here. There's no other word right here. So this is the 8,000. So we have almost like $8,000. So we go ahead and now there's no more comma right here. Now we're in the hundreds place. The 2's in the hundreds place. This would be the tens place, and we have something else in the ones place. So I am going to go ahead and erase this. Can I erase?
Yes, you can.
Okay. So next, okay, so like, what's the whole point of knowing like the ones, hundreds, and all these other places? We're at, the thing with math, and this is why math is so hard, is it builds on each other. Like you can learn science, you can learn a little bit of biology, a little bit of this, or like with literature, you can like read different like parts, but you'll still be able to master it. With math, it's like a ladder. You have to go kind of in order and build up. If not, or like if you like move on and you forget something else, like you will literally just fall down. And that's what's so beautiful about this course, is that it's like 4 weeks long. That way, like everything from the beginning is still fresh, and like throughout the class, I'll be refreshing you some of the old concepts. That way you can kind of like not forget.
Okay.
So next up, we're going to be doing something called comparing and ordering values. With this, we're actually going to be having different numbers. So let's say I have 342. Let's say I have 98 and 317. If you notice, I kind of lined them all up, not from left to right, but from right to left. For those of us with OCD, might want to do it the other way, but there's method to this madness. So let's say I wanted to add them up. So I have them lined up nicely because everything in the ones place is able to add up, everything in the tens place can add up, and everything in the hundreds place can add up. So let's say we go ahead and add this. 2 plus 8 is 10, plus 7 we have 17. Carry the 1. 9 plus 1 is 10. So for me, it is easier because I'm already recognizing that these are closer to add. It doesn't matter. You can just go ahead and add them all together for yourself. That's just the approach I was taking. So we have 10 plus 4, 14, plus 1 is 15. Go ahead and carry the 1. 3 plus 3 is 6, plus the other one is 7. So that just makes it a much easier compared to I haven't done this. If you're having to do all of this mentally without lining it up, it's a little bit harder. So let's say you have a question like this on the exam. They're going to give you a little dry erase board, or if not, they might just give you a sheet of paper. Go ahead and write it like this. it's a lot easier. And let's say I try to do mental math. If I have time, I can go ahead and double check my answer. And I can just see, oh wait, I forgot to carry the 1 over here. That's the beauty of showing your work with math. There truly is only one right answer. There's many ways of doing it. That's the beauty of it. I could have done it. I could have added, so let's see. This was the original method. Like, let's say this is the original question. But I could have gone ahead and added 317 and 98 together because those were the two smallest numbers. Add them up together. Let's see, 7 plus 7. 15. Okay, we get 15. 10, 11, carry the 1, that's 4. And then I can go ahead and then I can add 415 plus 342. It can happen sometimes when you are trying to add, you might be seeing something right here. You're like, oh, there's nothing else to add, and automatically just drop the 3 without noticing, hey, there was a 3 down here or that there was a 1 up here. So some people might want to stretch it out. Instead of adding all 3 things together, they want to just really focus in and add each one together like this. So now there's a 7, 5, and this is 7. So we have the same answer, but there was just a different approach. But still, it was much easier having used the place values of the 1s, 10s, and 100s when we were adding. So looking at these different methods, what method looks the easiest for you?
I would say the first and the last method because I've used both.
Okay, you use both. When it's like a lot of numbers, so let's say like we have a question that when it's like that, yeah, sometimes you just might want to break it up when it's like a question like this. So since we know that there's different methods, I do want to mention like when we get into the algebraic part and also with the geometry, I might do it in a certain method or like certain steps. I will teach you different methods. I'm not gonna like try to confuse you though. I'm not gonna show you like 30 different methods and then say like, hey, you can try to remember one of them for the test. I'll show you maybe 2, 3 of them, and then you can take whatever order makes more sense for your brain.
Okay.
So I'm gonna go ahead and erase this.
Yeah, go ahead.
Okay, so next up what we're gonna be doing is rounding. So one of the best examples is like if you ever go to like a garage sale and let's say that some lady you only show up with dollar bills. So let's say you only have and there's no Facebook Pay in this scenario, okay? With Facebook Pay, you can like send money through your Facebook account, and you're at a garage sale.
Yeah.
Let's say you want to buy a little dress or a shirt for $7. And you also want to buy my drawing skills are not amazing, and a little clock. This is pretty expensive for a garage sale, but we're gonna go with it. So if we add these two numbers up together, this is $19. You have to pay $19, so you owe $19. But you only have $26. You have a 20, a 5, and a 1. So the closest dollar bill that you have to is a 20. If you want to get these items, you can say, well, keep the extra dollar, because it's pretty close. It's not like you were paying with $100 bill and saying keep the rest of the money.
Yeah.
So by having done that, we rounded, and since this is the ones place, this is the tens place, we rounded to the nearest tenth.
Okay.
So let's go deeper into the theory of it. Let me go ahead and erase. So let's say we have this number, 2451. And we want to round to the nearest 100. Okay, so we have the 100. We're gonna look to the number to the right of it, which is like, well, it might be a little bit hard to understand, like, well, why the right? Like, let's say I get to select, I forget, like, left or right, what's the importance? Just think of it, the smaller number will determine. So we know, knowing that numbers go this way, it's gonna be the one to the right. So the smaller number, it depends on this. So according to our rounding is, so we have the numbers here. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So if it's 5 or greater, you round up. And you're like, well, why 5? Because but 5 is a number in the middle, but if you include 0, there's actually an even number right in between. So because 5 is on our rules of math that we can round up, we can round it to the nearest 100. This 5 kind of promotes the 4 to be a bigger number. So we round it to this number now.
Okay.
Let's try this again, but with a different number. Let's try it with so again, we're going to try to run to the nearest 100th. And this is where it can get kind of tricky. On the exam, they will have you, because it will be, so most of the questions will be multiple choice. Round to the nearest 100, it will have answers that will have been to the nearest tens, 100, or even thousands. So if you don't understand the question right, or you do it to the wrong place, there will be an answer choice that would fit the logic of it. So that's why it always helps to go back and reread the question. When I went to one of the trainings, they said most of the best way to pass the math portion is not necessarily with your math skill. It has to do with your reading comprehension. You're like, I just finished a reading class. It's come back to haunt me. Well, here it is. Just round to the nearest hundred. Think ones, tens, hundred. Okay, so we're talking about this part. So what depends? It depends on the number below it. So we know 4. 4 does not round up. So if the number is less than 5, we don't change anything. We don't change the number here. So we can just go ahead and say we don't round up. In this case, we can round down. We can say this. But the number, it doesn't let it be bigger. So like at the garage sale, whoever I was buying it from the garage sale, they're like, yay, they're fine getting the extra $1. But they might not be fine with getting like let's say I only had $18. They might be willing to haggle, they might not. So on the questions, it might even say, if it rounds up, what is the number? So now the question might be actually asking you 2 separate questions. Does it round up? And what is the number it would round up to? Or, excuse me, if it doesn't round up, what is the number it will stay as? So with reading and writing, it's sometimes okay to look at the answer choices because that can help jog your memory. But with math, just kind of like ignore the answer choices because those choices were like, they're not entirely random answer choices. Like if you remember with the tax test or TOS test, or even with the STAR, which is the new exam that they have now, they did not allow for, it was very obvious, like there was like the really dumb answer, like this answer has nothing to do with the question. They might have something that's just generated to be very close to what it would be. So just don't even look at the answer choices, but if you are stuck, go ahead and look. It sometimes helps to double check. The beauty about multiple choice questions compared to open-ended is, let's say you get an answer and it doesn't match the multiple choice, you know you did something wrong. Okay. So how do you feel with rounding?
Well, I'm actually okay with rounding.
Okay. Yeah, I know this is like the really basic, the first lessons are like super dull, but sometimes some people will have trouble, especially people who are ESL with like hundreds, thousands, and more vocabulary issue. So great, we can go ahead and breeze by. The next section is going to be about addition and subtraction. You're like, oh, I do that all the time when I order like my food from Chick-fil-A. I'm adding how much money I need.
Yeah.
Yeah, so like today's lesson is just going to be like very elementary. The next ones are going to be like much cooler. We're going to be, when we get into ratios and proportions, we're going to be adjusting a recipe for like, let's say it's a recipe for like 8 people. We're going to try to like half the recipe for like 3 people. So we're going to have to like change the ratio. That's going to be much more interesting.
Yeah, my problem is like fractions and I think, yeah, ratios.
Yeah, fraction, ratio, and percentages. I'm going to be doing a lot of examples about like clearance, like 60% clearance, and then like using your 10% JCPenney discount member card. So
Yeah.
we're going to be adding a lot of like life. It's honestly like the most applicable one out of all of the math sections that we're going to be doing. So we're going to go ahead and just breeze by this real quick. Like we're going to be going over whole number operations, multiplication and division, because they want to build up to the point of PEMDAS. But we will be getting to that. Today would just be a little dull. So let's go on with the rule of whole number. Yeah, because typically, With ratios, you're not dealing with whole numbers, but first we need to see how it is with the pretty world of whole numbers. So with here, I'm going to be getting into some vocabulary. So when I add something, a number adding another number, what I get is called the sum or the total. So here is where vocabulary will help you, because they're not just going to tell you in the question, add these two numbers together. They're not going to say 512 plus 49. They might have the question just like this, but not all of the questions are going to be as straightforward. The question might say, what is the sum of 512 and 49? Okay. Or if I'm subtracting, minus a number is called the difference. So I will have like 512 minus 49. So what is the difference between 512 and 49? A very practical example is saying like, well, let's say that your brother's this tall and you're this tall. What is the difference? The difference is just this little space right here between my two hands. But if I'm saying, what is the sum of both of your heights? Let's say you guys are trying to change a light bulb and like both of you stand on top of each other, that would be adding your heights together. Okay. Easy?
Yeah.
Okay. So we talked about addition and subtraction. Now we're going to be talking about multiplication. So with multiplication, when we get a number times another number, we get the product. Now, when we divide a number by another number, we get the quotient. And a quotient is just such an unusual word. You don't normally hear that outside of math. You hear the product, you can hear the sum, the difference. You hear the difference very often, but quotient, who comes up with that? Now with when you're dividing, there's actually other little vocabulary you need to know. So you have the dividend divided by the divisor, and all of that becomes the quotient. So you're like, but dividend divisor, like, they both sound the same. Most of it is spelled the same. I don't know which one's which. Well, you're kind of like thinking back like to the English language. Dividend is the one, if you erase the end, it's the one being divided. And normally the one who does something is called the in the end of the English language. So let's say I mow the lawn, I'm called the lawn mower. So this is the number doing the dividing. So let's say I have 8 pizza slices, and I need to divide it by 4 people. My quotient is 2 slices per person. So with these word problems, you're gonna see different things. You're like, okay, how do I divide it? Sometimes you just have to think, when you look at your answer, you need to think of it as 2 slices per person. Because let's say I have a word problem and I'm like, well, let me divide 4 people by 8 slices. That would be a very unusual. It's gonna say half a person per slice, and I'm like, We don't cut people in half. So you just have to look at it logically. Like, does it make sense? So 2 slices per person. Okay, that makes a lot more sense. Okay, so we have product, sum, difference, and we have quotient. They won't use dividend or divisor like very heavily in the exam, but in case you come across it, this is what it means. So can I erase? Can I erase?
Yes.
Okay. Okay, so with this one, I will actually talk a little bit about, let's go ahead and do a number problem with this, because this is gonna actually be a great segue into like ratios and proportions. So let me go ahead and write a question down. Okay, so this is the question. Okay, so 3 friends hosted a garage sale together and want to split the money equally. They made $154. How much does each person get? So we know that there's 3 people and there's $154. So we don't cut people in half or in any parts. So the people are the ones dividing. So they're going to be the 3 people right here. And we divide money. So logically, we divide 154 between 3 people. Okay, that makes sense. So we just get a calculator. Also, I do want to point out, since we're in the division part, mentally it's pretty hard to divide like this. So it's sometimes a lot easier when you divide. Go ahead and do this. Actually, I think I can go ahead and do this one. So 3 doesn't fit into 1, it's too big. So we're going to have to go into 15. So 3 times 5 is 15. So again, knowing our rules for the ones, tens, and hundreds place, whatever we are doing, it's going to correspond to up here. So we are looking at it from, if it was a 15, 3 divided by 15, we're going to put it up here. So minus 15. All right, that's a 0. We're going to now 4. Well, we don't have a 4. We don't know anything about a 3 doesn't fit perfectly into 4, so we're going to have to drop in another number. So we're going to have to drop a 0. So how many times it fit into 40? Well, if we have 39, and then 39 is the same as How many times does 3 fit into 39? We have 30, that's 10. 11 is 33. 36 is 12. That would be 13. That would be 13. 13 times 39. Okay, we get one number, so we have to again drop another 0, so we get 1. So how many times do we have to multiply 3 to get a close number? That's 5. We have to multiply 3 by 3 to get 9. And oh no! This is a repeating thing that's going to happen again and again forever and ever. So in order, just for the sake of clarity, because also these questions will want to know, like, well, technically, each person should get $51.33. 333 repeating, but in money, in the United States, we only carry money up to this place. So logically, if you go ahead and divide this in a calculator, you would get around $51.33. There will be, so when you multiply this by 3, you're going to be short 1 cent. You can just go ahead and give the extra person 1 extra cent. Like, have you ever shared like food with someone and it's like you try to like cut it in half, but like one side's bigger? The same principle here. Math is perfect, but real world and math don't always match up. There's a little bit of discrepancy just here. Like there's a 1 cent difference because you can't divide that perfectly. Okay. Any questions?
No.
Okay, I'm gonna go ahead and erase.
Is it okay if we stop right here?
Yes. Yes. All right, so tomorrow, I'm gonna get in contact with the IT department to see if we can get the teams going, because I think the video quality also works better with Teams. I know it's the same camera.
Yeah, I think the problem with the class was that not a lot of students were able to log in to their email, to their school email. And then when I joined Teams, well, I had my login, but most of the people that were in class, I know Yeli was I think she got her information. So, I mean, you should probably let her know that it's the same login that she would use to log in the computers in the classroom.
Yeah, it is the same one. I just it's the same one in the computer, but I also know like if students have been like with STC for a while, it resets, or there's different issues. So I'm just gonna go ahead and see my roster because I only have 4 people registered, and Yeli's not registered. I noticed that, so I need to get in contact with other administrators to see like if there was an issue like moving her, like adding her into the class. I know there's just been a lot of like issues communicating with people.
Yeah, well, there was more than 4 people in the class from what I remember. There was like 12.
Yeah, there were supposed to be 12. I'm not so sure what the issue is. I already got in contact to get like everyone's like phone numbers and like more email addresses. But I haven't heard back yet from like my administrators. They'll probably get back with me tomorrow, and if I can get in contact with the IT department, then I can like make sure everyone has like logins. If not, we're just gonna go ahead and do Zoom.
Okay.
All right. We'll see you tomorrow at 6 o'clock. I'll go ahead and send out another email.
Okay.
All right.